answers. Just send me a message. I'll fix that. I'll add that as an option and then give you credit for that. What does the other one say? Oh, and it's the same there. I'll add like that as an option. Yeah, I'll do that. Yeah, send me a message. Yeah. Usually we have multiple ways because everyone types things differently, but okay, we're going to do the flashcards a little different. So I want you to look through your flashcards and pick out 2 flashcards. And you're going to hand those in to me up here, and I'm going to ask the questions. So if they're not in question format, make sure I can turn it into a question or write it in like maybe on the other side, or somehow write it in a question so that I can propose that to the class, okay? So pick out 2 cards. You might have to do a little something to it so that it's in question format. Oh, we should play Jeopardy. I have a couple Jeopardy games. Okay, we'll do that maybe after spring break. I gotta find them. Jeopardy. Okay, so got 2? Do you have 2 set aside? 2? You're giving, yeah, put your names on them so I can get them back to you. Thank you for that. All right. Ready? Ozzy. Hopefully we'll get some like different types of questions, not all from the very beginning. Angel? Okay. Thank you. Thank you. Thank you. Thank you. Daniel? Thank you. Okay. All right, so take out a piece of paper or a notepad so you can type in the answers as I ask. Okay. So after reading Module 7 and Module 9, can you see how those 2 modules work together?
Yeah.
Okay.
A lot of the communication stuff gets explained pretty in depth between the 2.
Yeah. Like I've almost even thought of assigning module 6, then 9, then 7, because 9, ARP actually happens before the MAC address table can get full, so it's a quagmire. Okay, everyone ready? You can type it in a notepad or something, whatever works on the piece of paper. Okay, first question. I like this question. This is, so it's the command that allows you to see the ARP table on a router. So what command, write it down, what command will let you see the ARP table on a router?
Why was there two different ones? Did I not read that right? Did I not read that right, rather?
Are there two different ones?
It said there was in the Medicad, unless I read it wrong.
So that would not be uncommon, because you can look at an ARP table.
Given away.
Right, you can look at an ARP table, right? But then there's also sometimes a way to look at specific things about the ARP table. Okay.
I want to ask really quickly as well. For the quiz, one of the questions was, I missed a dash in the answer.
Yes.
I think you talked.
I'll fix it, yeah. So I'll go through and I'll manually look at that. Like another one was enter versus enters. So if you typed enter, it would have marked it wrong. I'll go through and I'll mark that right. And then I'll add that as an option for future quizzes. Sometimes we don't, if the quiz doesn't give you multiple ways to type something in. Okay, does everybody have that one? Okay. Okay, along with that, so this is on a router. Well, what would the command be on a Windows device? Now, the same is true here. There's actually, when you look at how to see an ARP table on a Windows device, there's a couple of different ARP commands on the Windows device, but the generic one that kind of just generically lets you see it. And then there's a way to get more specific information. Okay. The third question is, what is ARP? Okay, so for this question, tell me what the acronym stands for, but also tell me what its main job is. What is its main job? So what is the acronym, ARP? And really the acronym tells you what it does, but you have to be a little more specific than just that. I like this, okay. So everybody have that one? Okay, so number 4 is, what is neighbor discovery protocol? Okay, so neighbor discovery protocol. NDP. Okay, neighbor discovery protocol. Now this one, I want you to give me a little bit more of an in-depth answer, because underneath neighbor discovery protocol, we're going to find some other important aspects to this. Okay, because neighbor discovery protocol is responsible for a couple different things, like, and it has some different ways of discovering the neighbors. Right, so how does it do that? What are the mechanisms that it uses to discover neighbors? And what's its relationship to ARP, right? Like, what's the relationship to ARP? That's not a, so Caesar, that's not a protocol. That's a mechanism.
Okay.
What is the protocol used to mark a packet? Okay, so
I might have misunderstood it with one of the other ones.
So, what is encapsulation? Okay, so what's encapsulation? So answer that question. What's encapsulation?
Question, is the rest of it wrong, or is it just that?
Hold on, let me see. It's not, so that, yeah, so it's like, this is the process of that. It's a process.
Okay.
Encapsulation.
But then
It's not a protocol.
Yeah, so then it's just a mechanism then.
Right, right.
I'll fix it.
Ready for the next one? Okay. Let's see. What is used to send data from a source device to a destination device on a remote network? And I'll take a couple of different answers for this and we'll talk it through. We'll talk through why there would be a couple of different answers. So one would be if you're thinking about the OSI model. That would be one answer. Okay? And then the other answer would be an intermediary device. So maybe capture both of those. Good question. All right, so do we have that one? Okay, so here's the next one. So if you're sending a frame, to a local device. So what does that mean? If a frame's being sent to the local device, what is that telling us? You have to know that before you can answer the question, even though you don't know what the question is. So if I'm sending a frame to a local device, what does that mean? Yeah, it's on the same network, right? It's in the same LAN. It's in the same local area network. So if I'm sending a frame to a local device, what destination MAC address would be in the frame? Got it? Okay, number 8. If a frame is being sent to a remote device, what destination MAC address would be in the frame? Now that's kind of a MAC question, but it applies. Good one. Okay. Number 9. Let's see. What are the two logical and physical addresses called? Maybe a couple ways. Yes. I think maybe it should be, what is the logical address and what is the physical address called? So there's two, one logical, one physical. But there's multiple names that you could call them by. You can call them by different things. So I think that's what the question is asking. And then I'm going to add to this. Why is this important? Why is this important? The physical and the logical. Like, why is it important for what we're talking about as it relates to the MAC address table and the ARP table? Why is it important? That's another good question. Got it? Okay, so how are entries removed from the ARP table? How are entries removed from the ARP table? I'm glad we've had a nice smattering of questions and not like all similar. That's a good question too. So number 11 is, how is ARP stored? So once something gets in the ARP table, how is it stored? And another way maybe would be like where, right? How or where? And the same can be asked of the MAC address table. Okay, so this question is like this question, so I won't ask that one again. Okay. So there's another way to refer to the ARP table. What is that other way? So there's another way to refer to an ARP table. You might call it something other than an ARP table. Nice. Couple more. Are we ready? This is a good one. So how many types of messages does IPv6 discovery have? So that's kind of like this, right? So what is neighbor discovery protocol? And then I said, tell me kind of more stuff about it. Well, this goes along with that. So how many types of messages does IPv6 discovery have? So that's what I was looking for here, is the message types. So now this question is asking that, right? So this is for IPv6 neighbor discovery protocol. How many message types are there? And do you know what they do, right? Not just how many are there, but what do they do? What do they do? What do they do? Nice question. Okay, I got it. Okay, so let's see. So this one is asking, so how does ARP function? So what's the function of ARP? When the end device wants to message a local end device. So this is related to ARP, okay? And the other thing, how does ARP know if it's local? How does ARP know if it's local? So let's answer that. How does ARP know if it's a local device? How? How does it know? And the other question that goes along with this is, how does ARP function if it's a remote device? And how does it know? Okay, last two. Okay. So I'm going to add a little to this. Where do I find ARP tables? And the other part of this is ARP is a function of what addressing format? Okay, so where do I find ARP tables? Like what devices? And then ARP is a function of what addressing style or format? I don't know how I have 17. Oh, because that one was there. I do know. And then the very last one is name some security risks of ARP. All right. So everybody got it? All right, Lou, I'm going to start with you on number 1. What is the command to see ARP on a router?
I put down show IP ARP.
Yep, show IP ARP, right? Show IP ARP. There's a lot of protocols that fall under IP. And so that's when you know when to use the IP or not, like show IP interface brief, show IP ARP. I think you can also do show ARP, and I think that will work as well. We might have to try it, but show IP ARP, and I think, again, I think show ARP works. Okay. Windows device, Ozzy, how can I look at ARP? Yeah. ARP space dash A. And there's a couple of others, like you can do an ARP dash, I think a D. There's a couple of different ones. ARP dash S. Let's see, Joey, what's ARP's main job?
To connect IP addresses with MAC addresses.
Yes. And so what's the acronym for?
Is it address request protocol?
Not request, although that kind of works.
I wasn't sure. I was like, I don't know.
Let's see, I think that's one of our other questions. What's the R for, everybody? Yeah, resolution. So address resolution protocol. But address request protocol kind of works too, right? Because if you put an IP address in, or it needs to find the URL, it needs to find the MAC address. If it knows the MAC address, it can find the IP address. So it's like resolving which one matches up to the other, right? Okay, and so that's its main job. Is it matches up a MAC address to an IP address. Now there's one more thing that it does, and that is it actually is responsible for building the table. So it builds the table so that it can add the information into it. So when you get asked that question, you kind of want to think it does two things. It builds the table, and then it resolves the addresses. Right, it resolves the addresses. Okay. Marcus, what is Neighbor Discovery Protocol, NDP?
It has address resolution, router discovery, and directory service.
So what is it? That's the book answer.
Yeah, I really don't. I read it, I just didn't really understand.
Okay, so what did you just read? Read that part again?
That was like straight out of the book.
Yeah, so let's hear it.
Address resolution, router discovery, redirection.
Okay, so address resolution, what does that mean?
That's finding the proper address.
Which addresses?
Assuming it's like an address.
Okay, so it says address resolution, right? So what protocol is it doing address resolution for? What IP protocol? IPv6. So that's the first thing we want to know, is that this is IPv6's ARP, right? That's the main thing. This is IPv6's ARP. Now, ARP uses pings, or echo messages, okay? So the way that ARP uses the address resolution is it uses echo messages, which are like pings, ICMPs. It uses ICMPs. Neighbor discovery uses these different types of, these different message types. Okay, so we're kind of going to answer 13 right now and number 14. So we'll connect these. All right, so let's see. Someone raise your hand and give me what the different messages are. Who can give me the different, Matthew, let's hear them.
Neighbor solicitation,
Okay, so a neighbor solicitation, NS,
neighbor advertisement,
a neighbor advertisement,
router solicitation,
a router solicitation,
the router advertisement,
and a router advertisement,
and the redirect message.
and a redirect. Okay. That's so that if there's an error, or if it has to resend it, it can do it. Okay. So with ARP, address resolution, it sends an ARP request, right? It's like, hey, can I know what your IP address is, but can I get your MAC address? So it makes an ARP request. And then the host will do an ARP reply. That's if we're doing IPv4. Well, here, if we have IPv6, it does a solicitation. It does, hey, can I get your address? And they just call it something different. They just call it a solicitation instead of a request. Why? Just to be difficult. Why not just call it a request? I don't know why. And then same goes here. So when the neighbor is going to respond, it sends out an advertisement, like it's advertising its IPv6 address, or it's advertising its MAC address. Okay. Now, routers, when they need to talk to each other, and we're going to learn a lot more about routers, solicitation, and router advertisements when we talk about IPv6 addressing, so at the network layer. So we talk a lot more about those. But that's just the same thing as ARP, except it has more functionality. That's one of the things that makes IPv6 more resourceful, makes it more secure, is that it's got a little bit more fine tuning than regular IPv4 does. Let's see. Okay, Daniel, what is encapsulation? Yeah, the IP packet into the frame. And actually, does that happen all the way down the OSI model, or does it only happen from the packet to the frame? Yeah, it happens all the way down, right? And then if we're going up the OSI model, what is it? If we're going up from the frame, instead of encapsulation, it's de-encapsulation, right? De-encapsulation. It's de-encoding when we're taking it from the physical layer to the frame. Yeah, but de-encapsulation once we're going up.
So what was that explanation? I think mine's still too basic. What was that
Oh,
explanation?
what is encapsulation? So it's the process, if we were to put the whole definition and not relate it just to that layer, right? It's the process of packaging up each layer and wrapping it in a header and a trailer and passing it down the OSI model to where then it picks up the next header and trailer, and then it gets packaged up into a new PDU, it gets pushed down, right? So encapsulation, it's,
That's what I have. I just put the pause. I think mine's really basic.
Yeah.
Process of transferring data/information through the OSI layers.
yes, that's perfect. And the only other important piece of that is that it is picking up information, right? Every layer it picks up information. So at the data layer, we're getting all of the data, any of the JPEG information, any of the session layer information, it becomes the data. And then we move it down to what layer? What layer is next?
I didn't. Sorry.
Okay, after we package everything up into the data, wait a second. We're at the top. We're at the top. 7, 6, and 5. We have the data, and we move it down to what layer? Thank you. The transport layer, and it's going to get encapsulated. It gets wrapped up. What does it pick up here at the transport layer? Picks up ports. Ports. It's the only layer that gives you a clue. Transport layer. And now what do I call it? The segment. Okay, now the segment gets pushed down to what layer? Which one? The network layer. And then that process that wraps it up with a header is called, what is it, Joey? Encapsulation. And it picks up a source and destination, IP address, right? And now what is it called? A packet. We all know this, right? We're just having a little hesitation for some reason. Now it's a packet. It gets pushed down to the data link layer where this process happens, where it gets wrapped up. Encapsulation. This is where it picks up the header and the trailer. Now we learned this week, right, and last week, that what's inside the header? What's the first section of the header? The very first section. Frame start, which has the preamble in it. The second section of the frame.
That's the destination.
That's the destination address. What comes right after the destination address? The source address. What comes next?
Type,
The type. What comes next?
does data and type go?
What comes next after the type?
Is that FSC or?
No. Yes, the control. Okay, that's the header, right? That's the header. And then we've pushed everything down, the packet, which is also called the data or the payload. Now we have the trailer. What's in the trailer? Error detection and frame stop. Now all that process as we push it down is called what, Matt? The process as we're wrapping it up and pushing it down.
That's what I was saying earlier. I already forgot what it was. It's encapsulation.
Encapsulation. Okay, now we have the frame, and we put it on the physical layer, which is known as media or the channel. Okay, we got it? We've only done this like 27 times. Okay. So that's encapsulation. Are we all good?
Yep.
Yes. It's really, layer 2 is the last layer that the encapsulation happens, because then we have encoding. Okay, what is used to send data from the source device to the destination device on a remote network? Who is this to? Orgil, your turn. What is used to send data from source device to a destination device on a remote network? And there's kind of two ways we could answer this. Let's see. No, it's not weird. Let's see. What is used to send data? So if we have to send data from a source device, right, to a remote network, so over here, what do we have to use? Hold on. There's two different ways you could answer it. Yes, exactly right. So we would have to have the MAC address of the default gateway, so we would use the default gateway, okay? Now the way that this was answered on the flashcard was a little bit different. And so if you think of it in terms of the OSI layer, think of it in terms of the OSI layer, okay? What PDU does that job? Like, has the primary responsibility to get something to a remote network? Would it be the frame? It wouldn't be the frame, because where does the frame function? No. So the frame functions on the data link layer, and so where is that in relation to a network? Is that a remote network? No. Okay. So if the frame gets things on the local network and it moves things on the local network, what PDU has ultimate responsibility to get something to a remote network? The packet. Okay, the packet. An IP address is what allows us to actually leave the local network. Okay? Remember, we can't leave the local network to get to a remote network unless we have a default gateway present, first of all, and then that packet has to have the destination IP address. Because remember, the MAC address never leaves the local area network. So ultimately, that's when the destination IP address becomes important, because that lets the default gateway and the router know that it's got to get to a remote network. So the two ways you could answer this is you could say, oh, the default gateway is used, right? When data from a source device is destined to a remote network, the default gateway has to do that job. But you could also say the packet. The packet has ultimate responsibility for moving something off of a local area network and to get to a remote network. Okay? Let's see. Your turn, Caesar. So frame, so if we have a frame and it's being sent to a local device, what destination MAC address would be in the frame? What destination MAC address would be in the frame if we're sending it to a local device? Is that your question? That's not your question, is it? I don't think so. Don't let me ask anyone your own question.
Frame to the local device, isn't that? It's not the source, that's the destination address, right?
Okay, what destination MAC address? I don't think it's yours.
No, I can't.
Okay, so we've got source device. Here's a switch sending it to a destination device on the same local network, right? We have a frame. So we've got the frame start, and then we're going to have a destination address and a source address. So that MAC address goes right there. What MAC address goes into the destination? IPv6 is an IP address. No. What MAC address? What? We have a local device, okay? It is sending a frame to a local like a local device. What destination MAC address would we find in the frame? Don't overthink it. Don't overthink it. Matt.
So when I think of this question, I don't think I'm right though. I'm thinking of the broadcast MAC address, which is the Fs. I don't know, is that not what I'm?
Okay, so under which circumstance would it be all Fs?
If it's
So
not a known MAC address in New York?
are you guys listening?
If
Yeah.
If it's not a known MAC address, it would broadcast out trying to find that MAC address, so it'd be all Fs?
It would
I
be.
don't know if that answers the question.
Well, that's another way to answer the question, right? So if a local device is trying to send a message to a local device, something on the same network, and it didn't know it, it would use all Fs. It would broadcast it, right? Okay, but what if it does know it? This is more related to if it does know it.
It would just be the MAC address
The MAC address of what?
of the sending source of the source.
Well, hold on. Look at the frame. Okay, so here's the frame. This is the source. So let's say that this is AA, whatever. Okay, so we go AA, here's in the source. Okay, this is asking what MAC address would be found in the frame if we're trying to get it to the destination.
Destination MAC address.
The destination MAC address. Okay, again, don't overthink all of this stuff.
No, horrible part is I had source MAC / destination MAC.
Well, okay, let's just reread it, right? So we're talking about a frame. So it's on a local device. And it's going to, what destination MAC address would be in the frame if we're sending it to a local device? Or just the destination MAC address of the device. 1-to-1. Unicast, 1-to-1. Now, if that specifically said it didn't know the destination, then we would have the FFFFFFF. Okay, so what's the destination MAC address for multicast? No, multicast.
Oh, multicast.
Doesn't multi start with something specific and end with something specific? I can't remember the order.
So if I want to send a message to this group of people and not this group of people, I have to use a special MAC address. What is it? Nope. That's an IPv6 address. Okay, what is the multicast MAC address? Come on, a bunch of you answered this on a quiz and got it right.
It's 0100
5E, good job, yes. Say it again.
01005.
Everyone write that down. 01005E. So one to many.
That was the multicast.
So, what's that?
That was the multi-broadcast?
Not multi-broadcast, multicast. So remember, we have a unicast, multicast, and broadcast.
Don't they
Okay.
end with something specific as well, though, or is that a different one? 'Cause I could
It's
assume
random.
it's
Yeah.
Is there one that ends with 1? Because I thought I had read one that says it has the specific starter, but then it also has a specific end.
If you have a group that you've designated, then it might, yeah.
Okay.
Yes.
Is it 01/00/5E?
So it's 01-00-5E. And there's actually a range, but that's the one that it usually is. Didn't we see it? Okay. So everyone go do an ARP-A on your computer, 01-005E. Pull up a command prompt and do an ARP-A. Pull up a command prompt and do an ARP-A and look for the multicast. Okay. Now, this is an ARP table. And what's its job? An ARP table builds the table, and then it matches the IP address to the MAC address, correct? Yes? Okay, so the other thing just to notice here is see what the IP address usually starts with? 224, 224, 224, 224, 224. So what do you think a multicast IPv4 address starts with? 224. Okay, it's actually a range of 224 through 239, but you're almost always going to see 224. Okay, 224. All right, so what's next? Guillermo, when a frame is sent to a remote device, what destination MAC address would be inside the frame? Nope. So it's got to go to a remote device. What MAC address would we see for the destination inside the frame?
The one on the local area is the MAC destination address, right? We're sending with the destination MAC address.
So if we're looking up here, here's our device. And if it's sending something to a remote network someplace else, what's the destination MAC address inside the frame? It's important to understand the structure of a frame because it starts to make these questions a little bit easier when you understand what's inside there and how that frame is built. So where does it have to go before it can get off of the local area network? Okay, what specifically on the router? Okay, so if it has to go to the default gateway first, what MAC address would I find in the destination of the frame? The default gateway MAC address. Yes, does everybody understand why? Okay, because let's think about the way we talk about the default gateway. Okay, and again, I don't know how to tell you how important this is. The default gateway, it has an IP address from the local area network, correct? That's because it has to be able to talk, this device needs to be able to talk to the default gateway through its MAC address because it's on the same network. That's the only way that this device would actually be able to get the frame, which has the packet inside of it, to the default gateway so that the router can do its job. Because what the router does is it moves traffic to remote networks. So as long as the frame can get it to the default gateway, then the router will say, oh, look at that. It's destined for a remote network. Now I'm going to do my job. So the frame, the switch did its job, and now the router is going to do its job. Okay, the router is going to do its job. Gabby, there are two, is this your question? That's not your question. There's two types of addresses. What are they? A MAC address and an IP address. And why is that important for what we're talking about? Okay, I heard because the ARP table.
Sorry. The ARC table and neighbor discovery tables, they have to match up the two addresses together.
Okay, so the ARP table has to match up the MAC address, right? And then what? What does then the MAC address table have to do with that? So why is the MAC address table and the ARP table, like, what's important about why do we need to understand a logical address, which is an IP address, and a physical address, which is a MAC address? Like, what is the relationship how is it that they work together? And you're on the right track, right? Yes, Caesar.
It's because it's important for the communication purposes for them to be able to identify each other.
Let me think. I don't know about the term identify. Has anyone ever done a treasure hunt? Okay, where you do a treasure hunt and you get to a location and then you open up the clue and you can read the clue and then that clue gets you to the next location, right? And then you can get to the next location. That's kind of what's happening with the MAC address table and the ARP table. They're helping each other get that frame moved along the path, okay, until it ultimately can get to its destination either on the local network or get it to the router where then it can get the next clue. Oh, I'm looking at this. This is a remote network. Okay, I got to get this out of the router and on to the next step. Okay, so the importance of the logical address, which is the IP address, and the physical address, which is the MAC address, is that they are used in correlation with each other to move the frame, ultimately moving the data wherever it needs to go, whether it's on the local network or whether it's on a remote network. Angel, how are entries removed from an ARP table? Is this your question? No. Oh, you didn't have any cards. Okay. It is a set amount of time, and there's another way. What's the other way? Yeah.
Yeah, but
What command?
Clear ARC table?
I think clear ARP table will work. Just like clear MAC address table will work.
What was the other one, I'm sorry?
Clear MAC address table. Lou, how is ARP stored? Where is it stored?
I put it in the RAM.
In the RAM. Exactly right. It's stored in the RAM. How about MAC address table? Anybody?
I put in the switch memory.
Which would be,
I don't remember the internal switch memory.
what kind of memory would it be stored in?
ROM, isn't it? Sure it's
Well, that's a buffer. That's different.
I'm pretty sure it's ROM.
Are you?
I'm pretty sure it's ROM.
If I turn off the switch and turn it back on, are those MAC addresses still going to be in the table?
No.
So that would be what kind of memory? That would be RAM. That would be RAM. Okay? Now, something that you will learn in 150 is how to get those in ROM. What's another name for an ARP table? Anybody? Unless you are the one that gave that question, then don't answer it. That's another name for a MAC address table, but not an ARP table. The ARP cache, the ARP cache. Okay, so we did number 13.
Neighbor discovery protocol, bro?
Another name for an ARP table?
Well, that's the version for IPv6, right? Or is that,
Oh, okay, so you could say a neighbor discovery table. This is another name for an ARP table is ARP cache, the ARP cache. But yes, I mean, if we were to say, what is the IPv6 table, that would be a neighbor table. Yeah, that would be a neighbor table. What is the function of ARP when the end device wants to message a local end device? Function of ARP. Yeah, how does it know if it's local or not? So this is similar to this other question about the local and the remote. So what's the job? What's the function of ARP when the end device wants to message a local device? So this device wants to message this device. What's ARP's job? To find the MAC address. Yeah, it's going to do a request. It's going to do an ARP request. So that's ARP's job. On a local device, on a local network, it knows the IPv4 address. Its job is to find out what the local MAC address is of the destination. That's it. Okay? Now, how does it know if it's a local end device? How does our end device and ARP know that it's a local device and not a remote device? How does it know that? Yes, exactly right. It has access to the IP address and the subnet mask, and it does the math. It just does the math, and it compares it to its own. So if this computer is 10.204.68.27/23, and it's going to a 30/23, it compares it. It's like, oh, this is my neighbor. This is on my own local area network. But if it's going to 192.168.1.27/23, can it tell that it's a different network? Sure it can. It can tell that it's a different network. So what is the function of ARP if it's trying to get to a remote device? Anyone? Yeah, so ARP's job is to find the IP, is to find the MAC address of the switch, right? It's of the router. It's ARP's job to find the MAC address of the router. That's its job because it's building a table. It's building a table. Where do I find ARP tables? Where do I find, like what devices do I find ARP tables on? No. Router. Again, Gabby? The PCs. Didn't we just do an ARP-A on our PC? Okay. ARP tables are found on routers and end devices. Where are MAC address tables found? Switches, everyone? Where are they found? Switches. Okay, what are some security risks of ARP? There's a bunch of them. Spoofing, broadcasting. So what about broadcasting becomes a problem with ARP? Right. Yeah, if all these ARP requests are going out, like, you know, what's your MAC address? What's your MAC address? What's your MAC address? Next thing you know, your whole ARP table fills up, your network crashes. It's a very simple way to get a network to crash. And depending upon how large it is, it's not necessarily easy to bring it back up. Okay.
What happened to the AT&T network?
What's that? Oh, it happened to the AT&T network?
There was a bunch of networks that went out. There was a huge bunch of outages.
Was it a DOS attack?
They don't remember. Yeah,
That was recently, right? Yeah.
Last week or whatever.
Yeah.
It affected like 40 million people. It was.
I doubt if that was a DOS attack.
So is that similar to a DOS attack?
I don't know what happened there, but yes, it's a denial of service attack. Because what happens is when the ARP table completely fills up, there's no room for it to make any more legitimate ARP requests. Same goes with a MAC address table. If you fill up the MAC address with all these bogus requests, the MAC address table's full and no legitimate traffic can get on. And so it creates a denial of service. Yeah, that's why it's kind of easy to do. It's kind of easy to do.
It's kind of the same concept of a zip bomb.
Of a what?
Zip bomb.
I don't know what a zip bomb is.
I sent one to my brother years ago, but it was it basically causes it's a file that a computer will open, but it'll try opening itself. It'll repeatedly open itself over and over and over in an infinite loop until you run out the memory of the computer, which causes it to crash. So it can't handle that many programs opening. And it's a loop. It'll keep going until your computer can't handle it.
Right. Okay. Let's take a break. Let's see. Guillermo. Is this yours? Okay. Let's see. Kevin. It is, let me see what time it is. It's 7:29. Come back at 7:36. Daniel. Orgil. I think this is Ozzy. Here you go. 7:36. How's it going? Good. Really? I'm having terrible allergies. Oh. What are you working on, ACLs?
No, we're working on security and like hash public keys.
Oh, yeah, those are hard.
It's like, what? Can't do this. And we're all like, not sure. Because it doesn't do a great job on the web.
Agreed.
Yeah, but I'm just like,
You know when Skype was a thing? Where you could send a message attached to a or a file that would
Hey, Marcus, can you erase the board for me? Thank you. Go ahead and pass your flashcards up to me. No, Chase got a job.
What?
An IT, a real IT job. I know, it's networking as an entry-level network technician here at GCC. They take all my tutors. Yes, it's very,
To be fair, there was a lot of openings for here to do that kind of.
probably, yeah.
Yeah, there was like 3 or 4 last I checked.
Yeah, we're always understaffed.
It would be nice though.
Thank
Especially
you.
if you're like actively studying.
Yes. Thank you. Yes. You can turn in what you have finished. How many were required for this month? This module? No, this was a reduced one. 20 was, yeah, I mean, not required, but 20 is what, for full points. So I would turn in what you have, and if you want to add more, you can add more. Okay, can everyone take out their topology? Thank you, Marcus. This topology that I handed out last week, didn't I hand this out last week?
Yeah, you did.
And you're supposed to do this other side?
Yeah, we didn't do that.
We didn't do that?
I don't think so.
That's all you were supposed to do, circle the topology. Well, you were supposed to circle it and then put the addressing.
you were supposed to self-address them.
Right, using VLSM1E. Where is it? Thank you. Yeah, put your name on it and hand it in. Go ahead and put your name on it and hand it in. Okay. That's
wanna
not,
just fill-
well, that's not right. None of
That's
it.
not right, is
None of it's right, so,
What?
yeah.
Thursday.
Okay, so turn it in Thursday. Okay? VLSM1E. So we did this one together. And then on the other side, VLSM1E, it matches up to a VLSM problem you did a couple weeks ago. Okay, so.
A couple things. In my defense, this was done at 5
Okay, so I just published a VLSM. Okay, so VLSM 1G. It's due tonight, so you'll find it in the calendar. Okay, if you are not in the virtual machine, you might want to get in the virtual machine because we're going to address this in Packet Tracer. So you're going to do the addressing first, and then we'll backtrack and we'll add the addressing in Packet Tracer, okay? So VLSM1G, you're going to do the addressing, and then after that, we'll backtrack and we'll do some labeling and stuff. So let's get the VLSM done.
VLSM 1G, right?
1G, yep, VLSM 1G. If you're not in the VM, go ahead and get in the VM.
That's awesome GCC. Have you never actually clicked on the website and tried to log into Canvas?
Oh, so you have Maricopa.
You've got Packet Tracer on your computer, right?
Yeah.
Oh, perfect.
No,
Oh,
I
oh,
got
you
in.
got in. Is that,
I
did that
reset it.
work?
I reset it.
Okay, and that worked,
Yeah.
okay.
I don't know why it locked me out. It must have something number lock, caps lock or something.
Well, that's a good question. Alyssa, will you number your cards for me? You can finish the videos. Thank you. How's it going? Good job, Gabby. rubber band? Oh, it had a clip? Okay. Is it up here? Oh, here. Are these yours, Joey?
Yes.
Daniel? Blue. Is this one yours? Are these yours?
Mm-hmm.
Okay. Good job, Joey. Lou, are you stuck? Are you stuck?
No, just want to make sure everything's right.
Oh, before you hit submit?
I don't know, I did. Looked at it 3 times.
How many points did you get?
7 out of 10.
Oh, so you might have a typo error.
That's not what I did last time. My first one, I just made a mistake here. Or there's something right here. What the hell did I do?
All right, well, let's do it. We'll do it together. Just waiting for a couple more people to submit it at least once.
Write my thing like twice, but I got an 8 out of 10.
Okay, so I see a lot of people getting 7. So let's see what happens. Let's see if we do it. Let's see what happens if we do it together. Okay, so do you see it?
Yeah, it goes switches to the 4th octet. That's what it is. I stay on the 3rd octet. I bet you it's what everybody was doing.
Okay, so let's see here. Let's make this a little bigger.
You got me.
All right, so let's do a couple of these together. So human resources needs 1,000. What subnet mask am I going to use for 1,000?
You are going to use 22.
22. What am I going to use for 500? What am I going to use for 200? What am I going to use for 25? So we move from the 3rd octet to the 4th. The WAN? A 30. A 30. A 30. Okay, so let's do the networks first. Okay, so we're going to start with the address that they gave us, right? Except we're going to use we're going to get a new subnet mask, so we're going to start with that. So we've got that, and then the new subnet mask was a 22, right? Okay, now if we increment this address in the 3rd octet by what? What do we increment it by if it's a 22? We increment it by 4, so that's going to be a 192.168.4.0, and what's the new subnet mask? 23. Okay, so now we have a 23. So what does a 23 increment by? 23 increments by 2. Is everybody following that? Okay, and then we're going to do that in the 3rd octet. Okay, so that means I have to add 2 to the 4, right? So 192.168.6.0. What's my new subnet mask? 24. Okay, so now a 24 increments by in the 3rd, and that gives me a 192. Let's see. Okay, 192.168.7.0. What's my new subnet mask? 27. 27 increments by? What does it increment by? In what octet? The 4th. 192.168.7.32. What's my new subnet mask? 30. Let's go ahead and figure out the next one just so that we can do our little trick. 192.168.7.36. Okay. So I'm going to do this. I'm going to just kind of go like this. I'm going to plug this in here, and I'm going to just I got to fix all these, right? I can't just leave them like this, but I'll fix them in a second. Okay, so what's my first address? .1, so let's just go down the row. How about for my QC network? .1, my IT network, right? My management network. And what about my WAN? 33. Okay, so far, does everybody have that? Does everybody have that? Okay. All right, so now let's look over here. Let's figure out the broadcast for my very first network, my human resources network. So if I use the shortcut, I've got to look in the third octet of my next network, right? And I subtract 1 from this. That gives me a what? A 3. And then if I turn all of the host bits on in the last octet, 3.255. Okay, now can I bit this out? I could bit this out, right? Just to prove it. So 192.168.0.0/22. Okay, so let's just bit it out so that we can go back to our old school days so that we can see what we're, actually prove it to ourselves. Okay, so a 22, it's going to end right there, right? This is our third octet. Has everybody got that? Because we've got 192.168, and we're going to look at this third and the fourth. Okay, so if I turn this on, because I turn all the host bits on, right, that gives me a what? 2 plus 1, 3. And then if I turn all these on, what is it? 255. Okay, so we just proved that. Now to find the last address, what do I do to this one? I just subtract 1 from the host, right? I just subtract 1 from the host. So I'm going to come over here and I'm going to fix this to be 3 dot what? 3.254. Okay. Everybody get that? Okay, so let's do the next one. If I want to know what the broadcast address is of my second network, I can look at the third network and subtract 1 from this. Okay, so what is 1 from 6? So, and if I turn on all the host bits, it's going to be a 5.255. And if I subtract 1 from 255, 254. Okay. Now I want to figure out the broadcast address for this one, my third network. And so what do I have to do? So notice here, we're still in the third octet right here, right? The third octet. So we have to subtract 1 from the third octet. So that makes it 6. And then if I turn on all the host bits, I've got 6.255. And what is my last usable? 254. All right, so now what? What do I do here? So we've moved into the fourth octet, correct? Okay, so now I need to figure out this broadcast address. So if I subtract 1 from 32, that gives me 31. And if I subtract 1 from 31, 30, right? And then we can do the same thing here. We figured out that this was a 36, so this one will be a everybody and a 34. Okay, so let's see, a 35 and a 34. Let's hit submit, maybe. 10 out of 10. Okay, everybody get it?
I don't know why I got confused which is going to be a mild issue right now.
Okay, so I'm going to publish this packet tracer. Okay, it's right here, VLSM 1G packet tracer. And I want you to download it. And we're going to circle the networks. I'm going to show you a couple of different tools that you can use on Packet Tracer.
What was this under, I'm sorry?
It's right here. Let's see. It's in your modules. It's going to be right above the assignment. You'll probably have to refresh it. And if you just open up this tile, you'll be able to download it right there.
Under which?
So it's in week 8 in-class activities.
Oh, I see. Yeah, PKT.
PKT, yep, the PKT file. Okay. Let's see, it's this one right there. Yeah, click on that. And then you can download it. So open the packet tracer. Okay. So we're going to be looking at the assignment too, just to get some of the information.
Mild issue.
Yes?
It's telling me that it's unable to open it because the packet tracer is
Outdated? Okay, so what you're going to have to do is go into Netacad. You have to delete that old one and then go into Netacad and download the new one. It might be quicker to go into a different VM, because I think that's going to be associated with the VM. Let's see. Okay. All right, so first of all, notice here, there's some of these, there's already some information here, right? So the IT department had 200 hosts, okay? What department had 500 hosts? QC, okay. So what I want you to do is we're gonna go ahead and just update this labeling, okay? And you can do that by clicking in there. And then you can add QC. Oh, go into, go, you, yeah, it has to be on the VM. Yeah, so log in and then go to resources. Okay, so label all of them. So what about the one with 1,000 hosts? Okay, HR, So we're going to label that. And 25 hosts? Management, okay, management. Oh yeah, you found it, okay. So get that, okay. Okay, so we got that, right? The next thing is, I want to identify the networks, okay? So can I have a volunteer come up and circle the WAN? Lou, perfect. The WAN, so let's do the WAN first. We'll start with the WAN. Yeah, the one that says WAN. Perfect, thank you. And Caesar, pay attention just for a minute, okay, while you do that. Because when you had circled your networks, it's really important to include like the interfaces, right? So you want to get those interfaces in there and not just like the devices, okay? All right, so we've got that. And then let's see, how about the LANs? Can I have somebody come up and do the LANs? Perfect. Excellent. Yeah, nice done. Because see, again, you got to get that default gateway in there, right? Because that's part of our LAN. It's tricky. Very nice. Excellent. Okay. So I want to show you a couple of ways to do that in Packet Tracer, okay? And you might have already done this before. If you click on, let's click on this here, the draw freeform, okay? Click on the draw freeform. Did you miss something? Oh, nice, yeah. Perfect, the default gateways, good job. So we'll click on this. Okay, nicely done. All right, so let's just, and we're just going to do one right now. Don't do them all because I want to show you a couple different ways, okay? So let's click on freeform, which is this one right up here. And then let's do a fill color. And you can select any fill color you want. And then hit OK. Now notice we should all have a pencil. Okay. So we're just going to draw and circle our network. Okay. And then just close this. And you see how you still have the pencil even though you closed it? In order to get rid of that pencil, you're going to go click this little box over here on the left. So it's the free form. Let's see. So it's this guy right there, the free form. And then you click on that, which it's already highlighted, and then you can pick a fill color or do fill color. Now just go back there. There you go. Okay. Okay, and then just sit tight. Don't do another network because I want to show you a couple ways to do this, okay? So just do one network. Oh, that's okay if it doesn't have a color in it. Oh, okay. So let me show you how to erase it. Okay. So the way that you can erase it is if you come here and you click on this X right there, it's going to give you this box, and then you can click on that. Do you want to delete the selected item? And you can delete it. Now see how I still have the X? Okay, if I go and click on something, it's going to delete that. So in order to stop deleting, I'm going to go back over here to this box. So if you can always stop whatever you're doing by clicking back in this box. Okay? So I'm just going to go do my free form again. So I'm going to do a free form again. I've got my color already selected, right? So I'm going to come here. I'm going to just do, oops. I don't know. I already don't like that. Do you know why I don't like it? Why don't I like that? Because I don't have my default gateway. So I'm going to do it again because I want to get my default gateway in there. Let me select my color. There, it's better. Okay, everyone got that? Okay, and then we're going to just do another one, except we're going to use the oval. So this is just, it's an oval form, and you can see right here where this is highlighted. When I clicked on it, the first time it was highlighted here, now this is highlighted. And you can make it clear, or you can do a fill color. I'm going to do a fill color, and I'm going to change it to a different color just to make it easy to identify. So I'll make this one like a green. And again, it doesn't really matter, but see how I've got this X now? So I'm just going to go, I want to get that default gateway in there. Sometimes you can move it once it's on there. So then now it's just more of an actual form. And then let's do the box, which would be this one. So again, when I click here on the box, it shows this is highlighted. Now you can go back and forth. Once you've opened this up, you can go into a different one. But let's just, again, do one of the networks with a box, select a different color. I just want you to see the different things that the packet tracer lets you do. So I'll select maybe a nice blue. And then I get that in there, make sure I get my default gateway. All right, so we've got 2 networks left. We've got the WAN network, and then you should have one other one. So go ahead and do those however you'd like. On my WAN networks, a lot of times I like to use the square because I can kind of make it a little bit smaller. Just get in here just to this little point to point and squeeze it right in there. And then I'm going to just free form my last network. So again, just use whichever one you'd like just to practice. Just going to free form this one. Okay, so we should be able to see 5 different networks on here. Okay, 4 LANs, 1 WAN. Okay, all caught up?
Yes.
Perfect. All right, let's add the networks. Okay, I want you to add the network addresses. And so I'm going to do that with the text box right here where it says place note. I'm just going to click on place note. So somebody give me the network address for the IT department, 192.168.60/24. Okay. And let's see, how about if I want, I can also go in here, instead of doing a whole new box, I'll just go into this box and hit enter. Somebody give me the 5 QC quality control, 192.168.4.0, 23. So that time what I did is I just expanded that box. You can.
Never mind.
Yeah, there's a couple things you can do.
For some reason, matched my color, but now it's black.
When you're typing in it, it'll be red. Okay, and then let's go ahead and add the rest. So 192.168.00, was it 22? And then this one, 192.168.7. Was it 30? No. What was the management one?
7027.
27.
70, yeah, 27, yeah.
And then don't forget the WAN, right? Don't forget the WAN. And I'm going to actually put this in here. 192.168.732. 32.0 slash, oh, 32 slash 0 slash 32 slash 30. Okay. And get that in there. Okay. How's it doing? Looks good. Nicely done. Looks good, looks good. Okay, that looks good. Excellent. Okay. What are we missing? Yeah, we want to get some device IP addresses. Now, yours might not be showing your interfaces, like mine doesn't show the interfaces, which I kind of like that initially because it lets me see the network more clear. But if you go into options and then preferences, so I went into options and then preferences. I'm going to just click on show the port labels. Now this is going to make it a little bit messy to look at, but we'll at least see what the interfaces are so that we can give some addresses. And I'm going to pull some of this out of here just so that it's less messy. I'm just going to make it so I can see my router interface. Because I want us to address the router interfaces. So I'm just going to spread this out a little so that I can see things a little clearer. All right. What should we address first? Let's think about doing our intermediary devices, because I'd like to know that we all can do that. So how could we do these intermediary devices? So we're going to assign IP addresses, right? So we need to assign IP addresses to the intermediary devices. So where would we start? Where could we start?
The router interface would be the first one, and then the switch would be the last one.
Yeah, we could do that. Okay, so maybe let's start with the quality control department. Or let's start with the biggest one. It'll make it a little easier. Let's start with HR. So right here, G001, this is the what? This interface right here. It's a default gateway, right? And so I want you to apply an IP address to it. And we're going to put it on the topology. So not in the device, but I want to see it on the topology, right? So we can just go in here again and use our text box, and it's going to be 0.1/22. Now, if you feel confident that you know what you're doing, you could put just a .1, right? So I'm putting this here to represent this interface right here. I want to know what all the IP addresses are for the interfaces and for the important intermediary devices. Okay?
Did I miss, enabling the
Options,
Can-
preferences, and then show port.
okay.
Oh, yeah, so preferences, and then always show port labels. One more down. There you go. Yeah, so again, it kind of makes it messy, but
It makes sense.
I want us to start seeing how we're applying these IP addresses. Now, again, if you feel confident, you could, like, see right here when I do this one, the quality control department, I could just put like a .1 right there, .1/23, because I can see that the network is 192.168.4.0, and that if I'm going to apply this to G001, that's going to be a .1/23. So as long as you understand that this belongs to that network, you don't have to type out the whole thing. If you're not sure about it, make sure you include the whole address so that there's no confusion as to what it is. You might even put it like up by the G001 so that you know. So get some labeling for all of your default gateways. Which one? Which one are you looking at, Lou?
Are we just doing the default?
Yep, let's just do the default gateways for all of them. We'll do the WAN next. So get all the default gateways done. Kind of position them so that you know where they are. And you can even use a line, like if you want to point to one. So this here is a line. You can get a line, so you draw the line pointing at it. That's an option. Got them all? Okay. So go apply an address to the switches for management. Doesn't matter to me which one you use as long as it's from the correct network. Yeah.
Trying to do my line that goes underneath the bubble, not over.
I don't know how to, I'm not being, I did the same thing. It's like,
Other ones work.
okay, the other ones went over the bubble.
Yeah, that one works.
Oh, start in the bubble. I think if you start in the bubble. No. My pink did the same thing.
Okay. Sucks.
I don't know what the deal is, because I the little too.
Yeah. Try a bunch. Alright, whatever. Well,
But it works on some of them, right? Okay, so make sure all of your switches get an address. I used the second usable address. It doesn't matter which one you use, as long as you use something within the network. Okay. And then the last thing we need to do is we've got to address those WAN links, okay? We have to address the WAN links. So we can see here that the WAN is 192.168.7.32. Okay, so I'm going to use 33 and 34.30.30.34/30. And I'm actually going to just turn my ports off again just so I can look at things a little cleaner. Let's just see. Yeah, that's a little cleaner without all that. So strange. Okay. Get everything labeled. Where's your WAN addresses? Are they in there?
I don't think so, actually.
Yeah, and I don't see your WAN network either. And this WAN network, that's way too big. See, look at mine. It's just between this interface and that interface. That's the WAN. So you've encompassed all of this, and that's not accurate. So take that orange one and resize it. I think you can, hold on just a sec, come back out of there. I think you can, no, close that. This one. I think this lets you resize something. There you go. You gotta click okay. It might be easier to delete and do a new one. Yeah, okay. Oh, there you almost had it. Okay, so get that done and raise your hand so I can come back and look at it. Nicely done. Nicely done. Do you have your WAN addresses in there yet? Where are they?
Oh, I don't know. I'm
Okay.
trying to.
Get your switches. I know, yeah.
Figured out the box thing, but it's a mess. I tried, as you can see, I tried
Okay.
fixing it and I couldn't.
So let's get your default gateway inside this network. So you can just move this, see if you can grab that and move it. Yeah. Get that default gateway in there. Okay, this is the default gateway, and if there you go, that has to be part of your network. Same goes here. That interface has to be inside your networks. Yeah, see, that's what made this, see this? This is the default gateway right there. So it has to be included in that network. Oh, nice.
Well, I was just like, how do I fit them all in there? So I guess
Let's see.
what are you looking for?
Your WAN.
One there, one there.
Okay. And then you know where the
oh, excuse me,
network
this
is,
was,
right?
This was the network for the WAN, right?
Right, right.
And then this was for that one down there. And that was for
Hey.
You said you can do arrows on this, right?
I can do lines. I don't know. I've never seen arrows.
So if I do a line, will it just go from here and then I can use it?
Yeah, try it. Nice, yeah.
Hiding all of these up here.
Okay.
But it's fun.
There's a lot of people in the HR department.
All right. How we doing? Okay. Yeah, very nice. Okay, good. All right. So a little bit better understanding. So next what we'll do is we'll start addressing these, okay? So we won't do this one, but if you want to save it, maybe we will in the future. Hold on to it. So that we don't have to rebuild it. Yeah, I would save it. I want to just talk about one more thing before we leave. And that is on Thursday, we're going to do this lab 7.5.5. Okay, I just published it. I want you to go ahead and find this. It's in the in-class activities, and then I want you to download the student and partner one. You'll have to refresh your screen. You don't have to submit it, nope. Yeah, I would save it, so if we wanted to use it again, we can.
Should we log out of the
No, you don't need to. You can when we're done. So 755, view network device MAC addresses and MAC address table. Yeah, you can do the partner one. Word document. Just the one that says student and partner. Yeah, download that one. Yeah, don't do that one. Yeah, that one's just if you're doing it by yourself. We're going to do partner. Not tonight, but I want to look at it. I want to take a look at this. When you've got it, just pop your hand up so that I know. 755, it's in the week 7 class activities. Week 8, sorry, week 8. I wish it was only week 7. Okay. What's that? In-class activities, yeah. We'll do it Thursday in class. Okay. So when you come to class on Thursday, there's going to be a quiz that's open at 6:10. It's a timed quiz, kind of like the one today. There'll be no notes. I think it's 10 minutes, so just come in, do that, so we can get started on the lab, okay? All right, this lab is going to be similar to the packet tracers that you've been doing, and then like the one that we did on Thursday where we watched to see how the MAC address tables get full. So if we look at this right here, and we just see this topology as it is, what would we expect to see in switch 1's MAC address table, and what would we expect to see in switch 2's MAC address table if we just connect this and we haven't done any communicating yet? Say it again, yeah.
Back and forth between switch 1 and switch 2.
Right.
Addressing.
Exactly. So what we would see is we would see port F01 on switch 1, right? This one. And this is what it learned, and it would have learned about the MAC address on F01. So let's just call this like MAC, 22222, so that we know what it is, right? Switch 2. So it would see that, okay? Because they're talking back and forth, right? They're talking back and forth. And then over here on switch 2's MAC address table, port F01 would have learned about switch 1's F01. So we'll just call that 11111, right? So it's going to record that. Does that make sense? Okay. Now if we do a ping, right, and we'll call this AA, right, and we'll call this B, 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 B. Okay, so if A pings B and it goes back and forth, so what would we see in switch 1 if A pings B? What port would we see? F06, right? And it learned about what? A MAC address of A, so AA, right? Okay, so it goes bop, 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 right? And it comes across. Now, this AAAAA comes into F01, so what's going to get recorded in switch 2? F01, AAAA, right? Because it learned about A. Okay, now it goes out and it pings B, right? And B says, oh, I've received a ping, hello. So then B is going to respond. So B is going to go respond, and it comes ingress, right, into F18. So what's it going to get recorded over here? F18, B, 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 B. And then it's going to say, okay, I got to keep going. Now I'm coming into F01. So what's going to happen over here? F01. What is it? It records the B address. Okay, and then it just keeps going, and then it talks to PCA, right? So this lab, that's the whole point, is to see this process, okay? And then to start mapping so you can understand how these different recordings happen. Now you'll notice we've also going to be putting some IP addresses on VLAN 1, so we'll also get to see that mapping. And you'll see those inside the MAC address table, okay? And let me see. This first part is explaining that. It's about the mapping that's happening, okay? When you're doing this lab, I want you to pay close attention to the terminology that's associated with everything, okay? I want you to pay close attention to the terminology. And then let's scroll down right here. Okay, so restrict console access. If I do these commands, linecon 0, password Cisco, why do I do that and what am I affecting? Caesar.
We're doing it to protect, which one is it,
Linecon 0.
Is that the, what was it, privileged? That's not privileged. Is it the exec mode?
which one is, so privileged, how do you protect privileged, Marcus? Yep, enable secret is how you protect privilege, not with line console. Matt.
Prevent somebody from putting a cord into the network, and there needs to be a password, so that's the password to get into the network.
Right, and what kind of access
We're gonna ask that.
is that?
That's the,
Global user?
So far, wrong.
I'm trying.
I agree.
ask the question one more time, I'm sorry?
So what kind of access is that? You want to try again, Caesar?
No.
Out of band, out of band, out of band, out of band, out of band. Repeat after me. Out of band. The console's out of band, right? Okay. What about interface VLAN 1? Why do I need to set that up? Why would I set up an SVI interface, interface VLAN 1? For in-band connections using what? Like, what do we use for the in-band? What kind of a line do we use for in-band? The VTY. Line console, out of band. Line VTY, everybody. In-band, in-band. Okay? Now, another piece of this lab is looking at and understanding the OUI, okay? You're going to be looking at the OUI and also like looking at how long the MAC addresses are. It's going to talk a little bit about the different terminology for a MAC address, like a MAC address, a CAM address, a BIA, right? A hardware, a physical. As you're doing the lab, I want you to just look at all of the different ways that it's outlined in the lab, plus as you're on the command prompt and things like that, okay? So you're going to be looking at the OUI, and you might need to have another computer up because it has you look up some stuff. All right, so which one of these is the OUI, the yellow or the green? The yellow. The first 6 hex values are the OUI. What are the second 6 hex values? Yeah, the unique vendor ID, the unique vendor ID. And let's see what else. And then you're going to be looking at the ARP tables, okay, and doing a couple of things there. All right. So before you come to class on Thursday, I want you to read this lab top to bottom. It will make the lab go smoother, okay, and you'll be able to get through it quicker. It's a little bit of a long lab, okay, so if you read it all the way through ahead of time, it will help you get through this lab quicker. And VLSM1E, circle the networks and bring that in, okay? Circle the networks and bring that in. And you need to get it all labeled based on VLSM1E. We did that on February 23rd. If you didn't do it already, it's still open. Go in and do it. That's this one. Bring this in on Thursday. Second chance. Okay? Have a good night.